Temperature gradient is a vector quantity. Temperature gradient is a vector quantity, and its unit is Kelvin per meter. Temperature gradient is a vector quantity, and its unit is Kelvin per meter. Temperature gradient is a vector quantity, and its unit is Kelvin per meter. Its unit is Kelvin per meter. Paragraph. The rate of heat transfer. The rate of heat transfer. The rate of heat transfer is directly proportional to the products. The rate of heat transfer is directly proportional to the products. The rate of heat transfer is directly proportional to the products of area and temperature gradients. The rate of heat transfer is directly proportional to the products of area and temperature gradients. Directly proportional to the product of area and temperature gradients. So we're going to have H over T proportional to A theta over L. Then I have H over T equals K A theta over L. That's the rate of heat transfer. All these are what Opino has taught you. H over T, K A theta over L. H over T, Ka theta over L, where K is called the thermal conductivity. It's called the thermal conductivity. Where K is called the thermal conductivity. Thermal conductivity. And its unit is watts per meter per Kelvin. Its unit watts per meter per Kelvin. Some people write joule per second per meter per Kelvin. That's a long one. Watts per meter per Kelvin. Thermal conductivity. Watts per meter per Kelvin. Watts per meter per Kelvin. So that's all about conduction. Conduction takes place in what? In solid. It's as a result of temperature difference. Let's say I have somebody is trying to prepare soup, and he forgot the spoon inside here, and then he comes around again to pick the spoon. After some time, by the time he touches this place, he will feel a lot of heat sensation. Why? It has moved from here to this place. This is the region of higher temperature to the region of cold temperature, lower temperature. So it will now be conducted through that solid material. The material itself is not moving. The medium is not moving. That's the difference between convection and conduction. In conduction, the heated material is not moving. But in convection, the liquid or the gas, they have to move. We are going to look at that very soon. So in conduction, it is going to move as a result of temperature gradients. That's it. Theta. What's theta? T hot minus T cold over L. So once there is a temperature gradient, there will be heat flow. And once it is flowing, it's very easy for the body to allow it to transfer like this. This will continue until when the entire body is in a state of thermal equilibrium. What is thermal equilibrium? When all of us will now have the same temperature. That is it. So heat flow from higher temperature to lower temperature. In conduction, is a slow process. And it is by physical contact. You are touching it, and then it moves like that. That's conduction. And then this is the formula for rate of heat energy transfer. We have Ka theta over L. That K is called the thermal conductivity. Let's write. In convection, in convection, this occurs in fluid by actual flow of matter. This occurs in fluid by actual flow of matter. This occurs in fluid by actual flow of matter. That is, the transfer of heat by the motion of the fluid. That is, the transfer of heat by the motion of the fluid. The transfer of heat by the motion of the fluid. By the motion of the fluid. Full stop. It is due to density difference. The first one is temperature difference, but now density. It is due to density difference. It is due to density difference. It is due to density difference. Full stop. Convection can be forced or natural. Convection can be forced. F-O-R-C-E-D. You can force it. Can be forced or natural. Convection can be forced or natural. You know, the one that has to do with your fan blowing hot air away from you, that's convection, forced convection. Then the land and the sea breeze, that's natural convection. You go to the beach, it's been long we went to beach. Oh God, jam exam. No beach now, exam is here. So ash 300 plus, no beach. Now, if you go to the beach, the serenity of the environment, the coolness of the environment is what we are interested in. The sea breeze, during the day, what we have the heat flowing from the land to the sky, and then the cool air now come to replace them from the breeze, from the sea to the land. So you have sea breeze, and now occur during the day. In the night, you have the reverse process. You have the land breeze in the night. The land is now cooler than the sea during the night. But during the day, the sea is cooler than the land. But there's a density difference. And the same thing applies here. When you are eating water, applying heat to water, what happens? Water is a very poor conductor of heat. In fact, we have observed something that go and try it at home. Maybe you want to take your bath now, and then you now allow you first allow, maybe you have two taps, one supplying cold, one supplying hot. I like cold water to now be here, cold water down. Now let me pour hot water inside. You now open the one for hot water. The hot water are now there here. Now I said, if you don't stir it, if you now put your bowl to say the thing don't miss, or more you go cry. Because as you pour it on your body, that's hot water. The hot water is here. Number one, the hot water is less dense than water, so it will stay on top. It will never go down. It will stay on top. So by the time you now put the bowl and say they have missed, they have never missed. The hot water still remain on top. In fact, along the line, if you put your hand like this forcefully, you'll be seeing cold water here. The cold water remain because cold water is denser and it will remain there. Somebody was trying to do an experiment. What did he do? He inverted a tube and then he put some ice block here, wired ice block. Put the ice block in a gauze. And now put a gauze here. And then he put water here. Put water here. Then he was applying it here. As he was applying it, he was surprised that the water here began to boil and the ice block does not melt. The ice block refused to melt. The water here was boiling, because this is convection. So as we are eating this one, and the guy is not a good conductor of heat, he can't conduct heat down. So water is very, very poor conductor of heat, and that's one of the major reasons why it is not employed as a thermometric liquid. Very, very poor. That is it. So the same thing applies here. But when you are trying to boil water, naturally, ordinary water, you apply it, boom. What will happen? The water here now becomes heated. And once they are heated, what happens to them? They become lighter. They will not go up. Hot water will go up. Then the colder water, which is not, which is denser, will go down. Apply it again. Hot will go up, cold will come down. That's called convectional current. Convectional current. Why are we having that? Because we have different density. The one here is less dense because they are being heated. When you are heating water, they become less dense. They become lighter. They will go up. The colder water will come down. Like that, until the water begins to boil. So convection is as a result of what? Density difference. What about conduction? Temperature difference. It can only flow from here to here. If our head is at temperature of, let's say, 45, and my display is about 10, so it will now flow from that place to here. Temperature difference. When are we going to have convection? When we have density difference. What happened in this place? See, this is a natural ventilation. Convection is taking place. What happened? Cold air enter. What happened to them? They are heated in the room. They are heated in the room. Why? We are releasing heat. As we are breathing out, heat is coming out without our carbon dioxide. And then our cold air becomes warmed. What will happen to them? They will go like this. That's why we say open everywhere. So that as cool air is coming, the hot air can leave like that. That's exactly what we have. And that's convectional current. It takes place in a process. It has to do with fluid. That is that. Let's write. In radiation, no material medium. In radiation, no material medium is involved. 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 And it is the fastest of all the three processes. And it is the fastest of all the three processes. And it is the fastest of all the three processes. And it is the fastest of all the three bodies, of all the three processes. So that's all about the three modes of heat transfer. Conduction occurs in solid, convection in liquid and gases, and of course radiation, electromagnetic waves. And then conduction has to do with temperature difference. Then the one for convection, gradient difference in gradient. And then we have seen that radiation does not even require any material medium for its propagation. Now, we have to remember that black bodies, stroke rough. Okay, maybe I should make it very fast. Black stroke rough bodies. They have three major properties. Number one, they are good, they are poor reflector of heat. They are poor reflector. They are good emitter. They are good emitter, they can emit heat, and of course they are good radiator. Good radiator. Emitter and radiation are almost the same. They are good radiator, and they are also good absorber. So they can absorb heat. Black, rough bodies, then white, stroke polished, stroke shining surface. They are just the reverse. White, stroke polished bodies. What are they? Number one, poor, let's say good reflector. It does the opposite of that one. Good reflector. When you are going to mosque on Friday, the Hausas in the north, you wear white agbada because the white will reflect heat. Wearing black clothes in the sunny period shows that you have no knowledge of physics. So good reflector of heat are white and polished bodies. Poor emitter, and of course they have a poor radiator. We also have a poor absorber. If you go to the back of your fridge, there's a black materials there. They are painted black because they have to emit heat away. And if you go to the back of your refrigerator, it's always very hot. Always very hot. Poor absorber. So they are painted black so they can emit heat very well. Emit. From there, we go to the last part of this topic. That's talking about the thermoflask. The thermoflask is a device used for for maintaining temperature of a body. And it has so many features. One of the features is that it has a vacuum, and then that vacuum prevents heat loss by convection and radiation, prevents heat loss by convection, prevent heat loss by conduction and convection. By conduction and convection, that's what vacuum does. Then we also have the silvery wall. The silvery wall prevents heat loss by radiation. Silvery wall prevents heat loss by radiation. Prevents heat loss by radiation. That's what the silvery wall does. Prevents heat loss by radiation. And of course, we also have the cork. That one prevents heat loss by conduction majorly. Prevents heat loss. Evaporation is not heat loss. Heat loss by conduction. So when we're talking about heat losses, we're referring to three modes of heat loss: conduction, convection, and radiation. That's what they call lagging in physics. Lagging is done to reduce heat loss by conduction. But that one is not inside thermoflask. Heat loss by conduction. So there's a process we call lagging. When you lag, you are trying to cover with insulators to prevent heat loss by conduction. So I'm happy we are through with topic 19. We just take some examples, 10 questions, and then in the main class today, by God's will, we'll go to waves, topic 20. Okay, thank you for helping me with the classes. Make sure you help me adjust the class. The door at the back of the staff lounge should be open if it's not yet open for cross ventilation. So let's verify so that we can take some few examples. My goal is to take 10 questions before he must come, if he can be fast. so that we don't go back to it after this class. Is temperature a form of energy? No. Temperature, how can temperature be a form of energy? Have you heard of temperature energy before? Heat is a form of energy. By now, you know the difference between heat and temperature. Heat is a form of energy. Temperature is what determines the flow of heat in a body. Does it flow from left to right, depending on the higher or lower value? Let's go. Question 1. What is the rate of heat energy transfer? What is the rate of heat energy transfer in a body of area 2 meters squared? In a body of area 2 meters squared. In a body of area 2 meters squared. And thickness 20 centimeter. And thickness 20 centimeter. If the temperature at the ends of the body, and thickness 20 centimeter, if the temperature at the ends of the body are 75 degrees Celsius and 15 degrees Celsius respectively, if the temperature at the ends of the body are 75 degrees Celsius and 15 degrees Celsius, in bracket K equals 300 watts per meter per Kelvin. K 300 watts per meter per Kelvin. K. So I've given the formula today. That's the rate of heat flow. Let's go. H over T. The formula is Ka theta over L. I've been now. So what's the thermal conductivity? What's K? 300. How much area are we given? 2. Theta, what's the higher temperature? What's the lower one? 15. How thick is the material? That'll be 0.2 meter. Abi? Thickness. So that'll be 300 times 2 times 60 all over 0.2. That'll be 300 times 2. That's 300 also. Calculator. 180,000 joules. Or 1.8 times what? 10 raised to the power 5 watts. Because they talk about rates of heat transfer. Watts. So the rate of heat energy transfer, Ka theta over L. Question 2. Shall we? The vacuum between the double, we have answered it, but I just want to have the notes. The vacuum between the double walls of a thermal flask. The vacuum between the double walls of a thermal flask reduces heat loss through the vacuum between the double walls of a thermal flask reduces heat loss through option A, conduction and radiation. Conduction and radiation. A. Conduction and radiation. A. Option B, convection and conduction. 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 C, radiation only. Radiation only. Option D, conduction only. Class, what's the answer? Very good. Number 3, it is radiated by all hot objects. It is radiated by all hot objects. It is radiated by all hot objects in the form of, it is radiated by all hot objects in the form of, option A, infrared rays. Option A, infrared rays. Infrared rays. Option B, solar energy. Solar energy. Solar energy. Option D. Option C, X-rays. 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 Option D, light energy. Light energy. Class, what's the answer? Infrared. That is the thing that makes a body to become hot. When you absorb infrared ray, then the body becomes hot. Next question. Teapots are often silver coated. Teapots are often silver coated. Teapots are often silver coated to prevent heat loss by. Teapots are often silver coated to prevent heat loss by. Teapots are often silver coated to prevent heat loss by. Option A, conduction. Conduction only. Conduction only. Option B, convection only. Convection only. Option C, convection and conduction. Convection and conduction. Convection and conduction. Option D, radiation. Radiation. Class, what's the answer? Radiation. Save the wall. Next question. Thermoflask is designed to. Thermoflask is designed to. Thermoflask is designed to. Option A, store hot tea or water. Store hot tea or water. Store hot tea or water. Option B, prevent heat loss or gain. Prevent heat loss or gain. Prevent heat loss or gain. Option C, prevent heat gain. Prevent heat gain. Option D, prevent heat loss. Prevent heat loss. Class, what's the answer? Or gain. Not only heat loss. So if you put cold water inside your thermoflask, it will still remain cold. That is it. So it's not only heat loss, heat gain. So I will call it cooler. Right, another question. Heat transfer by conduction. That's number 5, Abi. 4. Very good. Heat transfer by conduction is similar to wave motion. Heat transfer by conduction is similar to wave motion because heat transfer by conduction is similar to wave motion because option A, there is increase in temperature. Heat transfer by conduction is similar to wave motion because option A, there is increase in temperature. There's increase in temperature. Option B, transfer of material is involved. Option B, transfer of material is involved. Transfer of material is involved. Transfer of material is involved. Option C, charged particles vibrate at right angle. 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 Option D, No transfer of materials is involved. No transfer of material is involved. I want you to think very deeply and pick one answer. Don't rush you. Let's comply. When they say adjust, please. It's almost over. Yes, what do you think is the answer? Eh? Eh? Option what? D. Very good. What is B? Which material are you transferring? So in waves, the material medium is moving, is being transferred. In conduction, is the spoon moving? Transfer of material, heat transfer by conduction is similar to wave motion, because in wave motion, what is being transferred is only the energy. The material medium is not going to move. There's increase in temperature, no. Transfer of material is involved. They are referring to material medium. The medium is a material. So charged particles vibrate at right angle. No. No transfer of material is involved. That material there is medium. The medium is not moving. During wave, the string is not moving. The particles of the string are just vibrating. So the answer is D, not B. D. Next question. Highly polished silvery surfaces. Highly polished silvery surfaces. That's number 8, Abby. 7. Highly polished silvery surfaces are. Highly polished silvery surfaces are. Option A. Poor absorber and poor emitter of radiation. Poor absorber and poor emitter of radiation. Poor absorber and poor emitters of radiation. Poor absorber and poor emitters of radiation. Poor absorber and poor emitter of radiation. Option B. Poor absorber and good emitter of radiation. Poor absorbers and good emitters of radiation. Poor absorber and good emitters of radiation. Option C. Good absorbers but poor emitter of radiation. Good absorber but poor emitter of radiation. Good absorber but poor emitters of radiation. Option D. Option D. Poor absorber but good emitters of radiation. Poor absorber but good emitter of radiation. Poor absorber but good emitter of radiation. Poor absorber but good emitter of radiation. Pick one answer, 5 seconds. What's the answer? A. Don't go and say they are good emitter. No. Emitting is different from reflecting. So don't go and say they are emitter. To reflect means when something falls on you, you send it back. That's reflection. To emit means from you are giving it out. So they are poor words. Poor absorber and poor emitter. Next question. The thermopile is a device for detecting. 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 Option A, radioactive radiation. Radioactive radiation. Radioactive radiation. Radioactive radiation. Option B, radiant energy. Radiant energy. Radiant energy. Jessica is not right, Radiant energy. Where's Oluchi? In top floor. I want to see Oluchi in top floor with the girl that I saw on Saturday. I was teaching you here on Saturday and class ended by 12:30. And I said everybody must be in the hostel by 12:40. By 1 p.m., I saw Lucy at Charity Bus Stop. I'm not even sure she had any physics that day. So she's going to tell me where. I'm saying it in the open now to know that I'm not happy with you. You've not been around for almost 2 weeks, and you are not feeling fine. But now that you are feeling fine, so you will tell me where you went to. And all of you that were not in the hostel, that I said you should write your name. I want to see you by 3. That's why I say you people should not be clapping for me, because you don't listen to me. You don't. The greatest love I can receive from you is obedience. Everybody now, we are moving like this. Go to the hostel, get here by 12:40. We are, sir, because we love you, sir. We are going to obey. That's love. Love is done after class. We love you, Mr. Adam, and then paper up and down. Love is obedience. Everybody, this is 12:30. That's the way I announced it on Saturday. This is 12:30. Everybody must be in the hostel by 12:40. About 25 people were not around. I beat them myself. Then I now saw some on the street, like Favor also. So I'm on the street. I saw Lucy at Charity Bus Stop. And then now speaking, we love you, Mr. Adams. That's not love, that's hatred. Love is obedience to instruction. Stand up. Yes, sir, we have. Sit down now. Yes, because we love you, we obey you. You know, that's why God loved Abraham, because Abraham listened to God. But all of you, we say, don't do this one, that way you're going to do. There are some people till now, they are still keeping space for people till now, till today. Till today, they did it. If you keep space, you will score high mark. I don't care. I will keep it. You'll be shocked when you fail the exam. Because you're just stubborn. Naturally stubborn. I'll finish clap now. You'll now be clapping. It's a lie. That's not a good clap. It's an hypocritical clap. Love is obedience to instruction. This man loved us. He was here Sunday to teach mass till to 5. From 1. He was here on Saturday. He's here now before biology class. Then the little he tells you, you do it. Little. So I want to see all those ones that they wrote your name, so I can spank you with Egba. The thermopile is a device for detecting A, radioactive radiation, B, radiant energy, C, X-ray, and D, the presence of electron. The presence of electron. Class, what's the answer? Radiant energy. Radiant energy, they are heat energy, heat form of energy. Number what? Very good. In the formation of sea breeze, I mentioned it today. In the formation of sea breeze, comma, wind blows from option A, sky to land. Option A, sky to land. Option B, sea to sky. Sea to sky. Sea to sky. Option C, land to sea. Land to sea. Option D, sea to land. Sea to land. Class, what's the answer? Sea to land. And that occurred during when? During the day, not night. Too. Land breeze occurred in the night. We have the reverse. One girl was chatting with me yesterday from the hostel. So I was worried. How can you be chatting with your phone? Where are you? I'm at home. What happened? We have to go Idil Fitri for Odun. See the chat too. So she said, good evening. So I said, where are you? She said, I just got home, not quite long. Sunday. And I said, is today the festival? Why did you go home? The festival is on Tuesday or probably Wednesday. So my dad said I should come home since we have not gotten any clothes that we want to wear to prepare everything before Tuesday or Wednesday. And I said, many Muslims are not going home. You're rushing home. Listen to me. This is a girl that scored less than 200 in mock the last month. Yes. Less than 200 in the last month. So I said, many Muslims are not even going home. You're rushing home with your poor performance in the last mock. Show that you are not serious. No, sir. I am really trying my best. I don't just know what is going on. But I believe God has a better plan. I am sorry, sir. I was about to ask, Gone home. Class is going on now. At last call, I'm not making mockery. 189. Last, there are people with 350 here, 340 here, who are Muslim, 339. I'm not saying they should not go home today or something. But at least, I think she was not around yesterday. And I'm sure there are some Christians that will go home today. They will come back on Friday. Their name has turned to Ramatu. Number what are we, Seth? Okay, number 10. I don't finish them. In a time of flash, come on. In a time of flash, come on. Heat loss by radiation is minimized by the heat loss by radiation. Rukia and Nofisatu. Heat loss by radiation is minimized by the heat loss by radiation is minimized by the option A, plastic stopper. Plastic stopper. Option B, cork supports. C-O-R-K. Cork supports. Cork supports. Option C, vacuum within double walls. Vacuum within double walls. Option D, silvered surfaces. What's the answer? Silver surfaces. So we are through with topic 19. 190 questions have been solved. Likely question for JAM. JAM will give you just 40. So make sure you read them and prepare. Next week is JAM. We used to write 70 days before, 80 days, but now it's next week. So make sure you read. No, the engineering student, you may not be offering biology. Don't waste that 1 hour. What do? Solve past question on your seat there. It's Monday morning. No need for gisting.